So far in this microprocessor 8085 instruction set, I had explained two group of instructions. First one is called data transfer instructions, then second one is called arithmetic group of instructions, and this is the third group of instruction which is called as a logical instructions. So before going into the detail of this logical instructions, first of all we should know about that logical operations as like logical ANDing, logical ORing, logical XORing, and then we'll go into the detail of all those instructions under this logical instruction group. So first of all we'll see about that logical ANDing instruction, logical ANDing operation. So here I had taken two number, one is A is equal to 79H and B is equal to 5FH, whose bit pattern is given in this form. So now as per the logical ANDing operation, what will happen? If both the input will have 1 and 1, then output will be 1. So here for the first stage, 1 ANDed with 1, their output will be 1. If there is any 0, then their output will be 0. Either 1 0 or both the input will be 0, then their output will be 0. So at the second stage, 0 ANDed with 1, their output will be, ANDing operation output will be 0 here. Similarly, from the third stage, 0 ANDed with 1, it will be 0 here. Then in fourth stage, 1 ANDed with 1, their output will be 1 here. Then from the fifth stage, 1 ANDed with 1, their output will be 1 here. Then 1 ANDed with 0, their output will be 0 here. Then 1 ANDed with 1, their output will be 1 here. And from the last stage, from the 8th stage, 0 ANDed with 1, 0 ANDed with 0, this will be 0 here. So their hex equivalent will be what? This will be 5, this will be 9. So this will become here. As a result, it will be stored into the accumulator. So this will be stored as a 59H. So this result will be stored into the accumulator, and in 8085 for this logical instruction by default, as like in the arithmetic instruction, by default in the logical instructions, one of the operand will be accumulator. So let's say this as a accumulator, and another operand need to be specified by the register or memory or as a immediate data. So this is our register here, whatever I had taken in this example. And after performing this logical operation, this is going to store the result into the accumulator itself without making any change into the specified operand as like register or memory or immediate data. So the second operand which is specified in the instruction is not going to change anywhere. Who will change? That accumulator content will be replaced by the result obtained after this logical operation, as like in this example it is A59H. Now we will see that logical XOR operation. Logical XORing operation. So let's say we'll take the same number here, that A is equal to, this A is equal to 79H and B is equal to 5FH. So their bit pattern can be written here as if for the 7 0 triple 1, and for 9 it will be 1 0 0 1. For 5F it will be 0 1 0 1, and F will be 4 times 1. So now in XOR operation, if both the input are same, then their output will be 0. Whether it is 1 1 or 0 0, if both the input are same, then their output will be 0. If both the inputs are different, either as a 0 1 or 1 0, then their output will be 1. So based on that, from this first stage, 1 XORing with 1, it will be having here the output as a 0. Then from the second stage, 0 0 XOR with 1, so this will be 1. Then again 0 XOR with 1, their output will be 1. From the fourth stage, both the input are same, so what will happen? Their output will be 0. Then from the fifth stage, both the input are same as a 1 and 1, so their output will be 0. 1 XOR with 0, so this will be here 1. Then again 1 XOR with 1, this will be 0, and from the last stage 0 XOR with 0, it will be 0. So their hex equivalent will be what? This will become here 2 and this will become here 6. So this result will be stored into the accumulator after this XOR operation. So this will be given here as a is equal to 26H. So for the same number, as like here also I had taken A is equal to 79H, B is equal to 5H, and here also for the XORing operation also I had taken the same number. A is equal to 79H, B is equal to 5FH, but as per the operation, this result is different from this A, like whatever we got it here as a 59H, but now for the same number, we got the result as a 26H. Now we have to see for this logical ORing operation. Logical ORing operation. So here again I am taking that same example. So here this A is equal to 79H and B is equal to 5FH. Their binary pattern will be 0 triple 1, and for the 9 it will be 1 0 1, and for 5F it will be 0 1 0 1, and this will be 4 times 1. So here as a output of this ORing operation, how it will operate. So here the output will be if there is any 1 in the input, either there will be 1 1 or both the input will be 1, then in that case output will be 1, and if both the input are 0, then their output will be 0. So let's understand with this example here. So from the first stage, 1 ORing with 1, their output will be 1. 0 ORing with 1, their output will be 1. Third stage, 0 ORing with 1, their output will be 1. From the fourth stage, it is 1. From the fifth stage, it is 1. From the sixth stage, 1 ORing with 0, it will be 1. From the seventh stage, 1 ORing with 1, it will be 1. And here, this logical ORing operation from the last stage, that both the input are 0, so this will be here 0. So their hex equivalent will be what? Their hex equivalent will be here, this will be 7, this will be F. So the result stored into the accumulator after this operation will be A is equal to 7FH. A is equal to 7FH. It will be stored into the accumulator. So in all these three logical operations, by default, the first operand is accumulator. Just here I am writing that first operand by default, this will be accumulator register. This will be accumulator register. And second operand will be what? Second operand we need to specify. So this will be either register or memory. Either register or memory, or this will be having immediate data. Immediate data in 8-bit. So this is the operation. Before going into the detail of this logical instructions, you must have to know about this and what will be the impact of this logical instructions operations over the flag, that will discuss one by one in this logical instructions group. So now we'll move for the explanation of the first logical instruction. So let's see.